Hello guys, how are you today? Here is a video to explain LVM partitioning. Maybe on one of my videos you saw something about LVM partition and you asked yourself, what is that? This video will try to explain it and show you some basic things about it to successfully understand and use the LVM partitioning. Firstly, what LVM means. It is Logical Volume Manager, a service to manage disk volume. Firstly, that technology is often used in the Linux world. So, to explain the utility and advantages of LVM partitions, I will quickly show you things about standard partitions. On a computer or server, standard partitions looks like this. In my example, I have a first partition in NTFS used for Windows. It's a small testing machine for this video, so I made a small 30 GB partition for Windows. Then I have a second partition here. It is formatted in ext4 and Debian Linux is installed on it. And finally, I have a third partition formatted in ext4 and is used for my Debian Linux data. So on my Debian, the /home is mounted in that partition. My Debian Linux system is installed here and my data are here. But with standard partitions, what happens if I want to enlarge a partition? As you can see in my example, I have 86 GB of free space. However, if I want to enlarge my Windows partition, I cannot enlarge it because the others partition are between it and the free space. So I can only enlarge this one because the free space is after it. I have the resize option and we see that I can enlarge it like this. It is also possible to move a partition, by example here to here, and then move the other partition to. I can show you quickly. But sometimes moving a partition can cause boot problems. That's what the warning tells us here. So depending on the case, it can be a bit complicated to move a standard partitions. I will still do it to show you if you really want to do it. Here is the free space. I will resize my Linux partition. I will do it like this. I get the same warning message. And now we see that I have free space here, I have free space here, and I have free space here. I could enlarge this partition either with the free space before or after. Or if I want to enlarge my Windows partition, I can do it like this. And there you go. Now it's at 46 GB partition. As you see, we may need to move many partitions if you want to enlarge a partition. And sometimes that kind of manipulation can be long and risky. In some case, moving a partition can prevent a system to boot properly and the maintenance will be required to repair it. Always make a backup of your data to another device before manipulating partitions with the partitions tools. Be ready to maybe reinstall your system if problem occur, or at least search to find a solution. Another things, a partition must be unmounted if you want to move it. If a system is installed on it, you must not be booted on that system. A way to do it is to use a Linux Live CD, open a partition manager tool, and then move or resize the partition you want. But, as we saw in the previous warning message, you need to be careful when moving partitions. And if you move big partitions, the more data they contain, the longer it will take to move them. So, if you have a 378 GB partition on a mechanical disk, it will take many hours to move. So we saw that it's easy to increase the disk space of the last partition if free space is available next to it, but it's a bit more complicated for the other partitions. It is sometimes more safe and easy to make a new partition configuration and reinstalling operating system when you need to make a change on partition layout. Normally, it is always a good idea to make a good planification of your system before installing your different operating systems. And now it is the good time to talk about LVM and show you in this video the advantages of using LVM. It takes off some of these limitations we have with standard partition and can make it easier to increase disk space. It is even possible to use a new hard drive to increase the disk space of an existing partition. So we are back to my machine. I will use it to explain what LVM is. I will revert what I have done in the past minutes. I will configure and show to you what we need when we need to deal with LVM partition. After, I will be able to show you advantage and disadvantage of using LVM. So for a simple explanation, you need three things with LVM: physical volumes, volume groups, and logical volumes. I will try to show you through examples to make explanation of this thing simple as possible. When I configure my LVM partitions, normally I always work with command line. I'm used to this. But for this video, I will try to explain the different LVM things with a graphical interface to make it easier to explain each of the things to do in the LVM configuration. So for this example, the partition manager I choose is lv-debian. So it's exactly the same machine as we saw before. I have the same three partitions already configured and the same free space. The first step to take is to create a physical volume for LVM. For that, it's quite simple. I will create a new partition, a new standard partition, but instead of choosing a normal file system like ext4 or xfs, like the one we use to install Linux, or ntfs for a Windows installation, I will format it as a LVM physical volume. I will use all the available disk space, so the 77 gigabytes, and I will click OK. So now it will create that partition. Once the physical volume is created, the second thing to do is to create a volume group. For now, it won't be very clear of what is the purpose of a volume group. Once created, and with some explanations in some minutes, you will see shortly what the LVM volume group is for. To create the volume group, I will right-click, select New, and since there is no more free space on the disk itself, it doesn't offer me the option to create a standard partition. Otherwise, it would ask me if I want to create a standard partition or a new volume group. So here, the step needed to create the volume group. You have to choose a physical volume. I will choose the one I created some seconds ago. This screen shows me the available physical volumes on my machine. If I had several not used physical volumes, they would all be displayed here. And I would just have to check the ones I want to use for my volume group. Many partitions can be selected here as member of the new volume group. If on this hard drive I had two not used physical volume and another one on another hard drive, connected to this machine, it would be possible to choose these three physical volumes. The total disk size of my volume group would be equal to the total size of these three selected physical volumes. So I will leave that as default. I will select the only one I had and my volume group will be 77 gigabytes. I also need to give a name to this volume group. I always try to use a meaningful name and I like to start my volume group with VG, followed by a dash, and in this case I will call it test. As example of name, on my laptop I named it vg-lab for laptop. You can write what you want, the name has no impact on the proper functioning, but it helps to have a meaningful name. So I will click on OK. So if I click on apply, it summarizes all things to apply. It will create a new standard partition, format it as LVM physical volume, and then it will create an LVM volume group named vg-test. Now, in my partition tool, we always see here my physical hard drive, but now there's something new here. My LVM volume group has appeared here, and we see all the free space on that volume group. A volume group is like a new disk, a virtual new disk. And on that disk, we can create some partition named logical volume. Once create, that logical volumes are the ones that we will format as ext4, xfs, or any other file system we want to use to install Linux, or to put data on it. In fact, to show you this, I will create one logical volume. When I click on the plus button, it opens the LVM logical volume config screen to create a new one. Here, we need to choose on which volume group I want to create this new partition, so I will choose the one I just created. And here is to specify the size I want for this new partition. I will set it to 12.2 gigabytes. I will choose ext4 as file system, and let's say I will use it to install another Debian on that machine. I will click OK. Then I will create another one. I will select again the free space. And let's say for my example, it will be another ext4 partition. It will be used to install Ubuntu Linux. Of course, only doing this step will not install Ubuntu or Debian. It's just an example of creating a partition. I'm creating two partitions that will be used in the future to install the systems I just mentioned. If, in your case, you're following this video to also preparing partitions for a future Linux installation, I suggest watching the next minutes of this video, where I will talk about some information to know to install Linux on a LVM partition. It can be useful information before preparing your partitions. So here I can create many logical partitions as I want, as long as there is enough space left here. I could have made a third one to put my data. For example, if for my Ubuntu system I want a separate place to store my /home partition, the one used for my user data, I can create that in a separate LV partition. And now, this is where we can talk about the advantages of using the LVM technologies. So one of the advantages is that if I want to increase a logical volume size, any existent logical volume on this volume group, it's very simple. There are no things about partition order, like I have shown with standard partition, and there is no limitation, like be able to increase only the partition next to the free space. This menu shows all my logical volume here, but it doesn't mean there is a specific order in these partitions. The logical volumes in LVM are arranged differently than standard partitions. So, if for example, in 2 months, a week and 3 days, I want to increase the disk space of my logical volume used for Debian, I will be easily able to resize it. And to show you that, I will resize and change it to 13.4 gigabytes. I can click resize and it works. There's no need to move that partition. So that was the first advantage I wanted to present you. And another advantage that I find pretty cool is if one day your hard drive is full. So let's say that after adding other logical volumes or enlarging my current partitions, I have no more disk space left here, but I need more space. It is possible to add another hard drive to my machine, format a partition on that new hard drive as a LVM physical volume, add that new one to my current volume group here, named vg-test, and all the space from this new partition will be added to my volume group and will be available to be added to any logical volume present on this volume group. So it's a very practical thing, but be careful with that. There's a little thing to keep in mind. If one of the two hard drives fails or are disconnected, the volume group will no longer be available and will be broken. So, it's very important to be cautious. If you have critical data on a LVM partition, don't use a low quality or very old hard drive to extend it. I already used that method when I managed virtual machines. In some hypervisor, sometimes it's not easy to enlarge a hard drive currently plugged into a running virtual machine. But sometimes on these systems, it is possible and easier to add a new disk. It is like this in Microsoft Azure, for example. So my technique is to add a new disk to that VM and then create a physical volume on that disk, add it to the volume group, and then the new disk space will be available to be added to my current LVM partition or to create some new one. With LVM, it is also possible to move all data to a specific physical volume and remove the old physical volume from the volume group if other physical volume connected to this volume group have enough space to meet your needs. It can be useful if you don't want any important data anymore to this old hard drive. It is possible to do that without any downtime. So LVM is often used for Linux servers, but in my case, since I have many experience with it, I use it too at home for my personal laptop and computer. I often use my workstation to test many Linux distributions. My strategy is to create a small 12 gigabyte partitions to install the Linux I want to test. All my Linux installation are installed on their logical volume partitions. Each time I need more space, for example, when I choose to use one of these Linux in my daily usage for some time, it is very easy to add space. And when I don't need a Linux distribution anymore, it is very easy to delete the logical volume used by this Linux distribution and free up disk space. That disk space will back to the volume group free space. We can also mention that LVM also have snapshot feature. So I talked a bit about the advantages of LVM. Now we will talk about the disadvantages and some things good to know about it. Of course, LVM is more complicated to manage. It adds an extra configuration layer, and your graphical partitioning tool must support it if you want to manage it with a GUI. I tried with gparted or the GNOME Disk Manager, and they do not support to manage LVM partitions, at least on the version I tested. So to show you with a graphical interface, I had to use blvgui. Otherwise, as I said, I always use the command line to manage it, but you need to know those command lines. And command line is not for everyone. So it adds a touch of complexity. So if you don't see any need of it, and none of the advantages I mentioned seem useful to you, keep it simple and use standard partition. As I mentioned earlier, if your volume group is spread across multiple hard drives, for example on 3 hard drives, and one of these drives fails and is no longer accessible, your entire volume group will be unavailable. You will lose all your data on these logical volumes if you cannot get back to life the faulty hard drive. Be careful here, I'm not talking about a case where a hard drive in a RAID becomes defective. That's not the same thing. In fact, I will make a little illustration to show you. For example, if you have 2 hard drives in RAID 1 on your server, and there's an LVM partition inside, and that partition is a member of the volume group vg-test, and one day you run out of disk space in that volume group, so you can add 2 more disks in RAID 1 to your server, create another LVM partition, a physical volume, and add it to the volume group vg-test to add the disk space to it. Later, again, you need to add more space and decide to add another hard drive. This time, the new disk is alone, not in a RAID, whatever the reason. You also add it to the volume group. If one of these things fails, whether it's this one, or this standalone hard drive, your volume group will be gone. On that case, maybe the only option left is to turn off your server, light a candle, get down on your knees, wait a few seconds, turn the server back on. And if you are very lucky, if the faulty hard drive works again, back up your data as soon as possible to a new hard drive. Another thing good to mention, some type of partitions require being in a standard partition. For example, an EFE partition need to be on a standard partition. That type of partition is normally necessary when you have a UEFI machine. If you install Microsoft Windows, or you want to create an NTFS partition to put some data that you want to access from Microsoft Windows, you cannot put it on a LVM partition. When installing Linux on a LVM partition, it's also a good practice to put your /boot on a separate and standard partition. Normally, only 1 GB will be okay for a /boot partition. For Red Hat Linux or Fedora, it is mandatory to use a separate and standard partition if your Linux is installed on a LVM partition. For Ubuntu and Debian, it is possible to put all your system on a LVM logical volume. But I already had some minor bugs when I did it. So now my rule is to always put the /boot mount to a standard partition. Some Linux distributions installation is not very clear too when we deal with LVM partition during the installation. Sometimes it's a bit more complicated and it requires a bit more technical knowledge. If you want to encrypt your Linux system partition, it also requires that you mount your /boot on a different partition, a standard partition. For MX Linux, a partition cannot be encrypted and in an LVM partition. Unless the latest version allows it, but last year when I tested, it was not possible. So when I design a hard drive config for a new machine, I think about all these things, what I will install on it on the future. I will show you my laptop hard drive configuration. I have one standard EFI partition, one big partition for my LVM stuff, and at less, some gigabytes of free space available to create some small 1 GB partition used for my /boot mount when I install a new Linux. Each Linux installed have their own /boot partition. If you are interested, I can make a video to show you how to install Linux in LVM partition. Say to me in the comment on which Linux distribution you want these instructions. For now, I showed you how to create these LVM things with a graphical interface. I will show you how to do the same things but with command line. So, no matter the Linux distribution you use and the graphical interface you use, these commands should work, or at least should be easy to install. But just before, I will delete all stuff I did on the previous minutes to reset my config. So, there we go. I'm back to the state before these modifications. I'm back with my 3 standards partitions and all the free space after it. I will open a terminal window and I will display the hard drives. You must have administrator or root privilege to do that. I will enter the fdisk-l command to list all disk and partition on my machine. So we see my 3 partitions. Now I will open the cfdisk tool, and here we see my 3 partitions again and the free space. I will create a new partition, so I will select new, take all the disk space, it will be a primary partition, and I will write my changes to save this change to the disk. Am I sure I want to write these changes? I will type yes to confirm. So we see my partitions. Here is the name of the partitions. SDA1 is the NTFS one used by Microsoft Windows. SDA2 is the one for my Debian system, and SDA3 is for my Debian data. And SDA4 is the new created partition, so I will exit the tool here. Now, back in the command prompt to create a physical volume. I will use the command pvcreate followed by the partition I want to use. If you don't know what it is, you need to go back to the cfdisk tool and note it. In my case, it's /dev/sda4. So I will use pvcreate and that disk path. It is very important to double check before pressing enter here. It's also very important to make a backup of your important data if you do any partitions manipulation on an existent system. Make sure you made a backup, because if you make a mistake here, this command will erase all the contents of the partition you enter here. So, if I accidentally write 1 instead of 4, which SDA1 is my Windows partition, it will completely format that partition as an LVM partition, and I will lose all my things in that Microsoft Windows system. Next, to show all available LVM physical volume on my machine, I can use the pvs command. So we see that /dev/sd4 is an LVM partition. Next, we need to create the volume group, so that will be with the vgcreate command. We need to specify the name we want for this new volume group. I will put the same name that I used on my previous example, vg-test. And we finally specify the partition that will be part of this volume group. Enter one partition path or many one here, as a volume group can be on multiple physical volume. So in my case, it will only be /dev/sda4. And finally, we will create a logical volume with the command lvcreate, followed by -n to specify the name. I will call it lv-debian, which will be a partition where I will install Debian Linux. Then I will enter -l, an uppercase L, to specify the size of the partition. I will create a 13 GB logical volume. And I will specify in which volume group I will create this logical volume. We will now verify all of this. We saw earlier that the pvs comment displays the physical volumes. So in my case, I only have one. But if I had others, they would be displayed here. The vgs command displays the volume groups and the available free space on it. These free spaces are available to create new logical volumes or extend your existent logical volume. So my volume group size is 67 GB, but I already created a 13 GB logical volume. so there are 54 gigabytes left here. And if I run the lvs command, it shows the logical volumes that I created some minutes ago. I will repeat what I did before. I will create one partition for a future Ubuntu installation named lv-ubuntu. So that's it for my LVM explanation. I describe a basic usage of it. Watch my YouTube channel to see more videos. I will make a video on how to increase the size of a logical volume. For example, if you run out of space and want to add space to it from the volume group, free space, I will also show you how to add a new disk to the volume group to add more disk space. I will also show you how to move data from one physical volume to another and how to remove one physical volume from the volume group. Do you want a video explaining how to install Linux on a LVM partition? If yes, write it in the comment and specify for which Linux distribution you need these explanations. So, I hope you enjoyed this video. Feel free to write in the comments if you're using LVM and how do you use it? Do you have some advices you want to share to the new one using it? So have a nice day. Bye bye.